Hi, everybody. This is my second in my series. I'm going to make more than one because I think that it's a very important concept. What I'm going to do is a side-by-side comparison with things that look very similar but are very different in practice. On the left, you're going to see that we have an algebraic geometry problem. And on the right, we're going to write a proof. And I want you to see how they're very, very different, even if they look the same. So we're going to start out with the one on the left, and we're going to start with a diagram. And you can see I have a labeled diagram here. And what we notice about this labeled diagram is that A and C are the measures of vertical angles. And we can see that I have an algebraic expression for them. But what I want you to notice is that I know that A is equal to C because they're vertical angles. So I know that that's the case. And so I don't actually even have to write this formula, but I'm going to go ahead and write it. This formula is we know that vertical angles are equal. Vertical angles, angles are equal. That's just something we know in geometry. And in fact, we've proven it several times. And on the right, I am going to prove it. But in doing algebra, we start with the formula, then we substitute. So instead of A, I put the 5x minus 27. And instead of the C, I put the 3x plus 5. And that is substituting. Now, there's no simplifying in this particular case. In the last problem, we had to simplify next. Now we go about solving it. And I'm going to start by subtracting 3x from both sides. And we get 2x minus 27 is equal to 5, and we add 27 to both sides. And we get 2x is equal to 32. And then I'm going to divide by 2 on both sides. And we get x is equal to 16. Now, in order to find the angle measurement, I'm going to have to substitute. So I know that A is equal to 5x minus 27. That's 5 times x. I'll write it up here a little higher. 5x minus 27. And again, I'm substituting. And that is 80 minus 27, which is 53. So A is 53 degrees. Now, in order to find in order to find C, I realize that A is equal to C, so I know that C is 53 degrees. Now, in order to find B, I need to know that A and B are a linear pair. Together they form a line. We also know that linear pairs are always supplementary. In fact, we can see that the two of them together make 180 degrees. And I could use A and B, or I could use B and C. It doesn't matter. I know, though, that A plus B is equal to 180 degrees. And that's because linear pairs are supplementary. And then, yeah, that's right. 53, I'm going to substitute, plus B is equal to 180 degrees. And again, I'm subtracting 53 from both sides. And I get B is equal to 127 degrees. So this is solving over here. We found the three values. The angle A measurement is 53 degrees. The angle B measurement is 127 degrees. And the angle C measurement is also 53 degrees. Now, over here, we want to prove that vertical angles are congruent. And the important thing about proofs is that you don't do steps and end up with something you didn't know before. When I started this problem, realize I had no idea what the measurement of angle B or A or C was until after I solved the problem and went through the steps. On the right here, when we do the proof, you have to start out by knowing where you're going and where you're going to end up. What we want to end up with is A is equal to C. Well, here's how we can do that. And this requires a little bit of thinking ahead of time. And you may or may not recognize that A and B have a sum. It's 180 degrees. Uh, B and C have a sum, and it's 180 degrees. And they both have B in common. And if we add A and B, and we add C and B, and we get the same thing in both cases, then A must be equal to C, in which case they must be congruent. Before I write a single thing on the paper, I have to understand that that's where I'm going, that I'm going to end up with A is equal to C. And the way I'm going to get there is by adding A and B, and they're equal to 180, and I'm adding B and C, and they're equal to 180. And when I subtract B and take B out of the equations, A is equal to C. And then I know that those vertical angles are always congruent. Notice that there's no values being worked with here. So I'm going to start with A and B. I can call them angle A and angle B, even though that's not exactly appropriate, but it's okay. As well as B and C. Are linear pairs. And the reason we know that, we could say that it's given, but it's really by the diagram. It's the way in which we created the angles. We made them linear pairs. They're part of a line. So I'm just going to say that that's given, or that it's part of the diagram. Now, because we know that linear pairs are supplementary, then I know that angle A, the measure of angle A, plus the measure of angle B, oh, I shouldn't use a capital. This isn't quite exactly appropriate, but it's close, is equal to 180. And I also know that the measure of angle B plus the measure of angle C is equal to 180. And we know that because linear pairs are supplementary. And I'm now going to do substitution. So I'm going to put angle B plus angle C instead of the 180 degrees. So I have the measure of angle A plus the measure of angle B is equal to the measure of angle B plus the measure of angle C. And I just did substitution. And now I can subtract the measure of angle B from both sides. And that is just the subtraction property of equality. Some people would just say, instead of being specific on which property of equality they use, they might just say, I did algebra. I prefer to be very formal if possible. And this is the subtraction property of equality. That's my short version of that. And we get the measure of angle A is equal to the measure of angle C. And that means they're also congruent, because when angles have equal measures, then they're congruent. So angle A is congruent to angle C by definition. And we can say the definition of congruence. Now, one more time, the important part is timing is everything. In this problem, we did the entire problem in our head before we wrote anything, and you must be able to do that. On this problem, on the left, we started with unknowns, we went through steps, and we found the answer. So I hope this makes it a little clearer, and I will continue with my series with another one. And I'll hope to see you there. Bye-bye.